we've done the fish kill day 4 notes, and then for homework we have the molarity calculations practice. So just practicing it, if we do our calculations and applying them. So just a reminder, we have to first convert grams of solute to moles of solute, and then we want to divide those moles of solute by liters of solution that's given. So here for 1, we have 20 grams of sodium hydroxide is dissolved in enough water to make 1 liter of solution. So what we're going to apply, we have 20 grams of sodium hydroxide is given. For every 1 mole, that's equal to the molar mass. So sodium is 22.99 on the periodic table, plus oxygen is 16.00, and hydrogen is 1.01. So that brings us to an even 40 grams of sodium hydroxide. So we have 20 times 1 divided by 40. Our grams will cancel, and we'll be left with moles. So our answer for this one is 0.5 moles of sodium hydroxide. We're going to go plug that in. 0.5 for every 1 liter of solution. So it tells us how many liters. So 0.5 divided by 1 is going to be 0.5. So this is a 0.5 molar, or concentration, of sodium hydroxide in this solution. And we'll continue the same thing as we continue. Here's decimals in liters, grams, liters, grams, liters again, grams and liters. Then we're going to apply that to the White River. So a population of fish exposed to water containing 0.000003 mole per liter of aluminum ions would begin to experience health effects. While our previous testing indicated that aluminum is most likely present in the river, we do not know the concentration of the aluminum. We do not have instruments in our classroom that are sensitive enough to measure such small amounts. So we need to send our river sample to a professional lab. In the lab, the river water sample is mixed with sodium phosphate. An aluminum phosphate precipitate forms as a result of the reaction, and it's then dried and weighed. The balanced chemical equation for this reaction that occurs is here. We have aluminum ions, cations, plus sodium phosphate. They switch partners here. This is a single replacement reaction. So our aluminum and sodium switch. We have sodium, and then we have aluminum phosphate that forms. That's our precipitate. The test of 0.5 liters of river water produces 0.000061 grams of aluminum phosphate precipitate. We can use stoichiometry to determine the number of moles of aluminum that must have been in the river water sample. So if we have our given, and we want to convert that to aluminum here, the answer for the river water sample, it contained 0. And we have 1, 2, 3, 4, 5, 6 zeros, 5 aluminum ions. And let's see, we have 1, 2, 3, 4, 5. So here, this is more concentrated when experiencing health effects. Ours is less concentrated here. So we want to calculate the molarity of aluminum ions in the river water sample. Remember that the volume of the river water sample was 0.05 liters. So you're going to take your given moles, you can copy your given moles, and paste it. That's for 0.05 liters of solution. So then take your answer. Make sure you have the correct amount of zeros. You have 1, 2, 3, 4, 5, 6 zeros and a 5 after. Divide it by your liters of solution. And our concentration now is, we have 0.00001 molar. So is this concentration of aluminum ions in the water high enough to be of concern? So compare now this number, 0.001, to the original. So how many zeros are here? 1, 2, 3, 4, 5, and a 3 at the end. zeros here, we have 1, 2, 3, 4. This is a higher concentration than what was given to start with. So at this concentration, they start to experience health effects. So ours is at a higher concentration. When dealing with very small decimal numbers, remember the fewer zeros they directly have after the decimal, the larger the number is. So this one has less zeros here. For example, 0.01 is larger than 0.001. So explain kind of what's happening for 2. Look back at the pollutants table on Fish Kill Day 1 assignment. What happens to the fish exposed to aluminum? So that's the vocabulary at the very bottom. So go back to that and help answer 3 here. Look back at the possible contaminant sources on Fish Kill Day 3 assignment, the reading portion. Which of the 4 possible sources could put aluminum pollutants into the river? Think, was it the coal plant, aluminum smelting, sewage treatment plant, farms? What was it that could put that aluminum into the river? So explain these in complete sentences. And then once you are done with the math portions here, we can look at one more math problem. It's a little more complex, like 4 here. Remembering, so we're going to have 63 grams is dissolved in enough water to make 100 liters of solution. So we have 63 grams as our given of HNO3. There are 3 oxygen in this compound. So that means when we're finding the molar mass, we have to account for that. So for oxygen, you're going to do 16 3 times. So 1 hydrogen is 1.01. 1 nitrogen is 14.01. So we're up to 15.02 with the first 2. And then oxygen, you're going to add 16 3 times. So plus 16, plus 16, plus 16. So 63.02. Grams of HNO3. That's the molar mass for every 1 mole of HNO3. So if we were to do 63 divided by 63.02, that would give us 0.9996, so we can round that up to 1 mole of HNO3. So 1 mole of hydrogen nitrate for every 100 liters of solution. So now we're going to do 1 divided by 100. So this one has a concentration of 0.01 molar. So making sure our units are correct as we go, I have units, grams, and what it is, grams, and the compound name, moles and compound name, moles and name, and liters of solution here. Making sure everything's right along the way. And that is how we find molarity and apply it to our fish kill.